Okay, welcome back to Mr. Hassan's Maths channel. I'm answering question number 7 from the June 2016 S1 statistics paper from Edexcel. This question is about normal distribution. It tells us about a machine which fills bottles with water. The volume of water delivered by the machine to a bottle is X milliliters, where X is such that it's normally distributed, and the first number here is the mean and the second number here is the variance. One of these bottles of water is selected at random, given that mu equals 503 and sigma equals 1.6. So basically we can say that X is such that it's normally distributed with a mean of 503 and a variance of 1.6 squared. This is the standard deviation. There we write the square of the standard deviation, which is the variance. It says first, part A says A part 1, find the probability that X is greater than 505. Alright, so to deal with this question, if it's normally distributed, if we've got normal distribution, which they've told us, and that's what it means here, X is such that it's normally distributed, that's what this means, we can use the table of values and the curves and the bell curve for normal distribution. Right? So that's what we're going to be doing here. So in order to do that, we have to think about the table of values that they give us, which I'll show you over here. The table of values that they give us here, this table here, and even the one on top, is based upon a bell curve like this, where the mean is 0 and the standard deviation is 1. Okay, that's what it's based upon. So whatever values we have to kind of standardize them, so we look at them in terms of how many standard deviations they are above or below the mean. The Z values here stand for the number of standard deviations something is above or below the mean. So if Z equals 2, it means that value of Z is 2 standard deviations above the mean, and the area here, this phi Z, is basically the probability of that occurring. The area is always to the left of this Z value. From this lower table here, it's always to the left of the Z value. So this is that phi Z, which is the area to the left of Z. Okay, the area to the left of Z. That's what that stands for. Right? So what we have to do is basically take our values that we're given and standardize them such that the mean is 0 and the standard deviation is 1 to find out how many standard deviations above or below the mean our value is. So what I'm going to do here is I'm going to take this value 505 and I'm going to standardize it. Now, how do we standardize it? We use the formula that Z equals, the standardized value is equal to X minus the mean over the standard deviation. Okay, so X is the score that you're standardizing, mu is the mean, and sigma is the standard deviation. So over here we know if we want to standardize this, we want to find what Z is. We know X is equal to 505. That's the score we're standardizing. We know that the mean is equal to 503, okay, as I told us in the question. And we know the standard deviation is equal to 1.6. So we can say the Z value is going to be given by 505 minus 503 divided by 1.6. Now what does that give us? Well, let's use the calculator and find out. Now that gives us, that's 2 over 1.6. 2 divided by 1.6, which is 5 over 4, which is 1.25. So the Z value that we're standardizing is, or the standardized value of Z of this 505 is 1.25. So the probability that X is greater than 505, okay, is the same as the probability that Z is greater than 1.25. Okay, that's what it's the same as. Now we can find that area in the curve. Okay, so let's have a look now. Let me just draw the bell. Now I mentioned that what we have in the table of values, if this is the Z value, which is 1.25, so basically what it means, the 505 is 1.25 standard deviations above the mean. So this 505 in terms of X, 505, this is 505, this is 503, it's above the mean. And how many standard deviations is above the mean? 1.25, because Z became 1.25. This is like converting it to the form where the mean is 0 and the standard deviation is 1. So this tells us that the value 505 is 1.25 standard deviations above the mean. And we want to find this area over here. Now, unfortunately, the table of values that I showed you doesn't give the area to the right of the z values. It gives you the area to the left of it. So what we're looking for is basically the area which is 1 minus the probability that z is less than 1.25. This is something I can find from the table, the area that z is less than 1.25. Now the whole of the area under this curve, when you have standardized it, is equal to 1. The whole area is equal to 1. So therefore, the area of this little bit is going to be 1 minus the area of this big part. So if I find what this is from the table and I do 1 minus that, I'll get my answer. So I'm going to go to the table and look for z equals 1.25. So if we go to the table and we look for z equals 1.25, okay, we can see that it's over here. Okay, and we get 1.25 is 0.8944. Okay, 0.8944. Okay, so if we take that value 0.8944, you have 1 minus 0.8944. So this is what that value we found in the table is. Therefore, we get our answer as 1 minus 0.8944, which is 0.1056. 1056. If we round it to one decimal place, to three significant figures, therefore we can say the probability that x is greater than 505 is equal to 1.06. There's the answer to part 1. Now we're going to do part 2. Okay, now it's telling us, I'll use the same diagram here. Find the probability that x is between 501 and 505. So there's 505 already drawn. Now what we notice is 501 is like 2 units to the left of 503. So it's below the mean by 2 units. And 505 is 2 units above the mean. Okay, so there's some symmetry here. Okay, there's some symmetry we can use in this question. All right, so let's just use that symmetry now. I can say that this is 501 and this is 503. So that distance here and that distance here doesn't look the same because I haven't drawn it quite right. Okay, those two distances are the same. Okay, that's between 501 and 503 is 2 units, and that's 2 units. In terms of z, this is going to be 1.25 standard deviations below the mean. Symmetrical. So z value is going to be negative 1.25 here. All right, z negative 0.125, negative 1.25, sorry. So we need to find this area in between those two values. Okay, we need to find the area in this region here. Okay, so again, we can use, in this case, because of the symmetry that we see, we can use that symmetry to our advantage. So I can see that this area here and this area here is the same. So if this area is 0.1056, then this area is also 0.1056. 0.1056. Those two areas are the same. And if the total area is equal to 1, so we can just straight away use the symmetry, say the probability that x is between 501 and 503 is the same as the probability that z is between minus 1.25 and 1.25. Okay, and we can see that this is going to be the same as 1 minus 2 times 0.1056, because the whole thing is 1. If I take away this plus this, which is 2 times that, I'm left with what's between them. So that's a very simple second part of the question, really, if you recognize that symmetry. So we're going to take this value here, multiply it by 2, and then do 1 minus that. Oops, 1 minus that, and that gives us the answer, which is 0.7888. 0.7888. So therefore we can say the answer is going to be 0.789 to 3SF. So the probability that x is between 501 and 503 is given by this answer to 3SF. And there we have part A of this question completed. Now we're going to go on to part B. Okay, now for part B, it says find W such that the probability that 1006 minus W is less than X, which is less than W, is equal to 0.9426. This is the information that we had from the first part of the question about the normal distribution of X with a mean of 503 and standard deviation of 1.6. Now, in this case, we have to think a little bit deeper. So let me just bring the bell curve for us to have a look at. Okay, so we have the bell curve here. Now, let's make it a bit bigger so we can focus on it a bit more. So you have two values basically. You have a value over here, which let's call that W. Okay, because this is quite a large area, so it's going to encompass more than half of this graph. So you're going to have a value on this side, and of course, because the area is 0.9426, it has to be more than 0.5, so it has to go onto this negative side of the z value. So it has to be this 1006 minus W must be below the mean, and this must be above the mean for you to have that much area between them. Okay, because if they're both on one side of the mean, then the area is going to be less than 0.5, because that area from here to there is 0.5. Okay, so this type of question, all right, I can spot something that's going to help us, because this is 503 and this is double 503, so that's, I think it's going to cause us to have a symmetrical situation. But if it wasn't symmetrical, it would be very difficult for us to answer. The only way you can answer this if it is symmetrical, and there is symmetry here, and I spotted that because of the numbers involved. Now, it's not that easy to maybe to spot, but I'll show you how mathematically we can show that there's symmetry here. Because I know that this value is the mean, which is 503, if we're talking in terms of the x values. These are the x values. Now, W means from the beginning, so I'll just try to show you in a way that you might hopefully understand. It means from the beginning, okay, all the way to this point, that's W. Okay, so that length is W. And the length from this point to that point is 503. Let me draw that underneath so it's not too crowded. So that point to that point is 503. So the distance between these two, this distance here, okay, the distance from here to here, well, that's going to be W minus 503. Okay, so we can therefore say that this distance here is W minus 503. Okay, that's that distance here. Now, if I'm considering the distance between this point and that point, and I'm comparing it to the distance between this point and 503. So from here to there is 503. And from here to there is 1006 minus W. That's that distance from there to there. So this distance here between them, this distance here is going to be equal to, is going to be 503 from here to the, from the beginning to this point is 503. Take away the distance between here and here, which is 1006 minus W. I'll put it in brackets too because there's a negative in front of it. So 503 minus 1006 minus W will give you this length here. So let's see what that gives us. You got 503 minus 1006 minus and minus gives you plus W. So that's going to be equal to, that's 503 minus 1006. As I noticed, so this is double, so that's going to be negative 503 plus W, which we can say is the same as W minus 503, which means that this length is also the same as that length. So there's symmetry here. So the area of this section here is the same as the area of this section here, and the area between them is 0.9426. So that's going to help me a lot now, because I can work out what the value of these two areas are. Okay, I can work out what the value of these two areas are. I know the whole thing is 1, so I can say that the probability that W is that X is greater than W. The probability that X is greater than W. Okay, the probability that X is greater than W is equal to, now I want to find this area here. Well, it's like the whole area, which is 1 minus this part, which is 0.9426. Now that will give me these two areas together, and these two areas are equal in size, so I can then divide this by 2. Alternatively, I could say that the whole of this area from here to there is 0.5. Okay, and I could then do 1 minus 0.9426 divided by 2 and take that away from 0.5. I could have got that as well, but this is easy actually. This is actually easier. I mean, because yeah, I think this is easier. So you do 1 minus 0.9426, which gives you these two areas, divide by 2, which gives you one of them. Okay, so I can say the probability that X is greater than W, therefore is going to be equal to, so let's just put this in the calculator. We have 1 minus 0.9426 divided by 2. Okay, that gives me 0.0287. 0.0287. Okay, so that's this area over here, 0.0287. That's the area that we're looking for here. So we want to find the value of Z for which this is true. Now, again, we can look at the table of values. Okay, and we can look for the Z value. Now, again, we're looking for the Z value where the probability that X is less than W is equal to 1 minus 0.0287. Remember, the Z value that we're going to find is where the area is to the left of it, okay, not to the right of it. That's the table we're going to use. So we're going to take this value here, we'll do 1 minus that value, and it gives us 0.9713. So we're looking for the area 0.9713. So we're finding the value of Z for which this is true. Therefore, Z is equal to, let's look for 0.9713. 0.9713. Do we have it here? Yes, we do. We've got an exact value of 1.9. So this is the area to the left of this Z value. Okay, so 1.9. Okay, so we have what we're looking for, 1.9. So let's go back. So we know that Z is equal to 1.90. Okay, so that's what we were looking for there. Okay, now let's, we need to find what the value of W is now. So we have everything we need. We can just unstandardize the score. Remember, Z is equal to X minus mu over sigma, the standard deviation. So in this case, we know Z is 1.90. X is the W we're looking for. Mu is equal to 503. And sigma, as we know, is 1.6. Okay, that's given in the question already. All right. So now we can find what W is. So we have 1.90 is equal to, remember, X, which is W, minus 503 divided by 1.6. So therefore, we can say W is equal to, we can say 503 plus 1.90 times 1.6. Okay, so we're going to take 503 plus 1.9 multiplied by 1.6. That gives us 506.04. 506.04. So therefore we can say W is equal to 506. That's the answer for part B. That was a bit of a tough one actually. Okay. Recognizing this symmetry was key for this question. If you didn't recognize the symmetry, it's almost impossible to do it. Okay, so that's why I was looking for that symmetry, and the fact that that was 1006 and the mean was 503 kind of give us an idea. All right, but I hope you understand why these two lengths are the same. Okay, that's the key to answering this question. Okay, it's a bit of a tough one actually. Part C, it says, following adjustments to the machine, the volume of water delivered by the machine to a bottle is such that mu is equal to 503 and sigma is equal to q. So now we've got the new situation that x is such that it's still normally distributed, but the mean is 503 still, but the standard deviation is q. So this variance is q squared. So now we've got a situation that says, given that the probability that x is less than r is equal to 0.01. Let me just get rid of some of these lines first. All right, so I've got this ready for us. Okay, so we know that the probability that x is less than r is equal to 0.01. All right, so we got to find the value of r and q. So let's have a look at this first. So if the probability that x is less than r is 0.01, that means the area to the left of r is very small. So r can't be over here. It must be somewhere over here. It must be somewhere on the negative side. Okay, so r must be somewhere on this side over here. Okay, let's say that r is over there. And the area to the left of it is 0.1. Okay, now let's deal with that part first and then this part afterwards. So now what we can do is we can look at the table of values, okay, from what we have. But this time, because the area we've given is a area which is one of these more exact type of values, we could use the table on the top, the smaller table now. So let me bring that across. Okay, so there's a table. Now in this case, this stands for the probability of the area to the right of these z values. We know that this z value is going to be negative, right? These are only positive values of z, and these are the probabilities to the right of those z values. So because of the symmetry of the curve, there's going to be a value on this side which is a positive version of r, okay, which will be, let's call it r dash, which will be such that this area will be 0.1, and the value that we find here, we just have to put a negative sign in front of it because we know it's going to be symmetrical on the other side. So if I find 0.1, 0.01, be careful, mister. See, I almost made a silly mistake again. It's 0.01, 0.01. Okay, if I find the area of 0.01 to the right of the z value, and we can look at the probabilities, 0.01 is right over here. Okay, this is 0.01. So I know that this z value here is 2 as a z value, so I'll write it underneath. As a z value, this is 2.3263. 2.3263. So I know the z value here, this is 2.3263 standard deviations above the mean if the area to the right of it is 0.01. So something which is on this side where the area to the left of it is 0.01, says less than r, that must be 2.3263 standard deviations below the mean. And the mean is 0 when we're considering the z values. So it's negative 2.3263. Remember, this is the actual value of the mean, which is 503. So I know that according to this situation, we can say z is equal to negative 2.3263. Now with that, I can set up an equation because as I said, z equals x minus mu over the standard deviation sigma. So in this case, we know that x is equal to r. Okay, the x value, okay, the actual value, this is like the z value, x is equal to r. We know the z value is negative 2.3263. And we know that, we do know mu is equal to 503. But what we don't know is the standard deviation, we've called it q now. So we can set up an equation from this. We can say z, which is negative 2.3263, is equal to x, which is r, minus mu, which is 503, divided by q. So with this, we can set up one equation, we can say negative 2.3263 times Q is equal to R minus 503. So that's like one equation we've set up now. Okay, we can also set up another equation using the other bit of information, that the probability that X is greater than R plus 6 is 0.05. So let me write that down. The probability that X is greater than R plus 6 is equal to 0.05. Okay, so now let me get rid of this here on this side, because we use this to find that. And I'll use the same diagram. So now we know that this here is R plus 6. Okay, let's say this is R plus 6. Okay, this would be minus R. Anyway, this is, no, that would be R, sorry, minus R. Okay, that's R plus 6. We know the area to the right of it, because it says X is greater than R plus 6, is 0.05. So this area is 0.05. Okay, let me just make sure I've written that correctly. Yep. Okay, so now I can use the table to find the corresponding Z value for this, because I know the area to the right of this is 0.05. So if I look for 0.05, it's actually the very next, no, it's up here, sorry. This one, 1.6449. So Z is equal to 1.6449, and it's actually positive now. It's on this side, because the area to the right of it is 0.05, so there's a small area to the right of it, so it's positive 1.6449. That's the value of Z for this second situation. So now we can use the same formula. In this case, we have X equals R plus 6, and we have Z equals 1.6449, and we have mu the same, 503, sigma the same, which is Q. So let's set up another equation. So we have 1.6449 equals X, which is R plus 6, minus mu, which is 503, over sigma, which is Q. Okay, so we can set up another equation. We can have 1.6449 times Q equals R, and you have 6 minus 503, 6 minus 503, which is negative 497, minus 497, and that's equation number 2. Now we have a pair of simultaneous equations. We can solve them simultaneously. Minus 2.3263, it's a long question here, equals 6R minus 503. That's equation 1. And we have 1.6449 times Q equals R minus 497. Okay, that's equation 2. So now if I subtract them, I'm going to subtract them upwards. I'm going to do 2 minus 1. You're going to have this minus that. So we're going to have 1.6449 minus, which is plus 2.3263, which gives us 3.9712 times Q equals, the R's cancel out when you subtract, and you're left with minus 497 minus, which is plus 503, which gives us, you got 503 minus 497. Okay, which gives us 6. So this is going to be R minus, it's just going to be 6. The R's cancel out, of course, don't they? Okay, you're going to end up with 6 on this side, with the R's cancelling out. So therefore, we can find what Q is. Q is going to be 6 divided by 3.9712. So we're going to do 6 divided by 3.9712. Which gives us 1.51087. 1.51087. It continues on. So we can say, therefore, that Q is equal to 3SF 1.51. Okay, there's answer for part for Q. Now we can find R simply by rearranging one of these equations. I think this second one looks easier. So we can say R is equal to 497 plus 1.6449 times Q, which is 1.51087. I'll put it in its exact form. So R is equal to, so we're going to take our calculator value that we got for this R, for Q, sorry, we're going to multiply it by 1.6449. I'm going to add to it 497. And that gives us 499.4852, 499.4852, ... Therefore, R is equal to 499 SF. And there we have the answer. Very long question, a bit complicated, but doable. Okay, especially part B was a bit more, you have to think a little bit about it. This one is a bit, it's kind of not that difficult, but it's just a long question. It's the last question of the paper, so it's got a few parts to it, and that's fine. So as I said, I'm doing these older questions upon request. Anyway, so other questions you might want to watch from this particular paper can be found in the area over here when you click on the link, and other questions from this topic of normal distribution from S1 can be found in the link that should appear in this area. You can subscribe to my channel by clicking on the link over here, and you can look at the description to see other material that you might be interested in. Thank you for watching, and see you soon.